Uh, in the last session, we saved all the parameters that we required to plot the GM over ID curves in Cadence. And then we said we have two options. We can plot it in either Cadence or in MATLAB. So if you don't have MATLAB license or if you are not familiar with MATLAB, you can plot them in Cadence itself with simple steps. So that will be explained in this tutorial. So, so if you want to plot in MATLAB, you can skip this tutorial and you can go to the next tutorial where we'll explain the how to plot in MATLAB. So in here we will plot in Cadence itself with the help of little bit Ocean scripting, and I'm saving the state that we saved earlier in the previous tutorial, and I'm just running the simulation just to see if it is working as it is. So we have all this parameter we got here with respect to VGS. Now I just want to introduce the Ocean script here. Uh, If we start writing the Ocean script from the beginning, it will be a little bit difficult. But there is an easy way here because we can directly save the Ocean script. You can see the option for that, save Ocean script. So if you save the Ocean script here, uh, we will get the Ocean script for this simulation. We will need not write anything over here, but we will get this, and it is very easy to understand once we get the script. So I am renaming it as uh, NMOS OCN. OCN stand for ocean. Okay, save the script, and you can see that script over here. So I'm closing here and I'm opening the script in the simulation library. In the simulation library, you can see it is the nmos.ocn. So if you open the nmos.ocn, it is very easy to understand that all the details are here. All the details of our simulation is here. The simulator is where is the simulator, what is the simulator, where is the design, the location of the design, and the analysis. You can see the definition file also. The definition file that the save._op.sh that we added to instruct the cadence to save all the operating point, and our analysis is DC, and we are sweeping the V1. V1 is our VGS. The DC parameter sweep we are doing from point 2 to 1 with this step with 50 steps, and our length is 180 nanometer, and our width we give 5 micro, and temperature is 27, and all this all the information is here. Then we add a lot of parameters that to be saved. So you can see all of them here. It is GM by GM over GDS. So it is the final answer, and this is the expression for that. And it is asking to plot. Uh, so we are after every expression we get the instruction to plot. That is because we give this we give the instruction to plot everything. That's why we are getting plot option after every expression. That is something that we don't want, so we can remove it. We can remove it in two ways. First, we can deselect all the plotting here, disable the plot and save the original script again. Otherwise, we can just delete those lines. If you delete the line, then it will not plot. So, or you can make this line as a comment. So just inserting the semicolon, it will not operate this line. So I'm just deleting for simplicity. Okay, before deleting and plotting all the GM over ID curve, let us simulate uh, the same Ocean script. So I'm not saving the file. We will manipulate this later. So now I will show you how to run the Ocean script. So In the Ocean script, all the information regarding our circuit and our simulation is here, so we need not open any schematic to run the Ocean script. All we want to need is just this command window. In the command window here itself, we can load the Ocean script. So the command to load is LOAD, and in the bracket, in inverted comma, we have to give the name of the Ocean script file. In our case, it is nmos.ocn, and just press enter. It will run the simulation itself because the script has all the information regarding our circuit, our schematic, our parameters, everything. So just press enter, it will run. You can see it is running here. The DCCP is happening now, and finally you will get all the plot without even opening. So for running the Ocean script, we need not open any of these. We don't need them. So even without closing, even with closing everything, just load this Ocean script here. It will run the schematic, and it will run the simulation, and it will give the result. So this is the easiest way to generate an Ocean script. We can generate the Ocean script from ADEL itself. I will show once again. Open the schematic. As we shall do whatever we want, and I'm loading the state that we saved earlier, and we can run the simulation directly here, or if you want the Ocean script of whatever we did till now, you can simply save the Ocean script here. So this time I am disabling all the plots because I don't want all the plots to have start all the plot at a time. Step by step we will plot everything. So I disabled all the plot. Now I save the Ocean script, and I'm using the same name as nmos.ocn. Okay, override the file. Yes. So here is my file. So now I have all the information regarding GM by GDS I have here, VOV I have here, GM by ID I have here, GM FT and ID by W and FT into GM by ID. So all the parameters I have here. Now only thing I want to do is to plot. So there are different options available for plotting in the Ocean. So we will start a simple technique, a simple command. So that is Ocean, OCN, Y versus Y. So this command allows us to plot any variable with respect to any other variable. So we are using this easy to understand. Ocean stands for ocean. Y is the axis versus another axis, and plot in the bracket give what are the two axes we want. So we want one wave x and wave y. So in the x axis, so first of all let us plot GM over ID with respect to overdrive voltage, that is VOV. So I want x axis to be VOV and the y axis to be GM over ID. So y axis I should write question mark wave y. Now here I want GM over ID in the y axis. So I just copy the GM over ID here and paste it and save the file. So if I run this Ocean script, if I did everything correct, let us see is there any bug. If there is no mistake, it should run all the schema, all the simulation, and it should plot VOV in the x-axis and GM over ID in the y-axis. So let us see whether it is doing that or not. I'm loading the Ocean script nmos.ocn, and we are getting one error here. Let's see what is that error. So we don't need a space in between this. I think we don't need a space here. So I think that is the mistake that we made. So let us save and run it once again and see what happens. Yeah, now we are successful and we got the VOV in the x-axis and GM over ID in the y-axis. So let us close it, and so I'm commenting that, and just copy paste. Now I want to try a different thing. So now I want GM by GDS in the y-axis and VOV in the x-axis. So I copied GM by GDS here, save. We are plotting one by one now. So once we simulated the value, we need not simulate it again. We can just give this command directly to the command line window. So I copy the command and I can simply execute the, I pasted it and I can simply execute the command to get the plot. So this is the plot of, in the x-axis we have VOV and in the y-axis we have GM by GDS. So similarly we can make any plot that we need, and let us plot the FT. So I want the next plot VOV with respect to FT. So I copy FT, and in the Y axis, that is wave Y, I paste it. So entire command now I can copy and simply paste in the CIW window and get the plot. So let us enter. So this is the Y axis in the gigahertz, and this is the FT, and the X axis is the overdrive voltage. Similarly, you can make another wave with overdrive voltage in the x-axis, and in the y-axis, suppose I want ft into this expression ft into gm over id. So copy, just paste it, save, and copy the entire thing, paste it, enter. So this is the curve in the y-axis. Now we have gm ft into gm over id and VOV in the x-axis. So you can do this, or either you can uh, run the entire script to get the plot. So I'm copying this and paste it and running. So now it will do the simulation again and it will plot what we give this to plot. So we are expecting a plot of ft into gm over id with respect to VOV. So this is what we got. So till now we were plotting one by one. So if you want all the plot, we can do that also. For that we have to uh, add some more command like new window. So now I will add a command like new window. So it will open a new window and plot the first plot, and after that I want to add a sub window. And in the sub window it will plot the next graph, and I'm giving another subwindow to plot the other graph also. So now let us say on run the index script, and I hope there is no error. If there is no error, we should get all the four plots at a time. So let us plot it. Let's run the simulation. So I'm just loading the ocean script and it will run. So what we predicted is correct. Now we got all the four plots at a time. So I think it is the familiarizing with ocean script is easy. We can just simply add a simple command and we can get what we need. And let us save this. And so we got what we want from the NMOS, but for a single length. But we want the same parameters for different length. So before going to different length, I want to show the curves with respect to GM over ID. So let us change these equations. In these expressions, we are plotting all with respect to VOV. So instead of VOV, I want to plot things with respect to GM over ID. So first curve, let it be like GM over ID with respect to VOV. Then second graph, I want to plot GM by GDS with respect to GM over ID. And the third FT, I want to plot with respect to GM over ID. And FT into GM over ID, I want to plot with respect to GM over ID. So just save it and load the ocean script here. It is very simple. Just press enter and we will get the all the plots with respect to GM over ID now. So now we got all the curves. Now all the x-axis is GM over ID. So the first plot, the x-axis is VOV, and this one, two, three, all these three plots, the x-axis is GM over ID, and the y-axis is the parameters like FT, GM by GDS, and all. Till now we didn't use ID by W, so there is nothing special in using it because we can plot any parameter we want. If we want to plot ID by W, just copy that, and if we want, we can add one more sub window, or we can just replace some parameters and insert that. So I don't want to, I'm lazy, I don't want to simulate once again, so I just copy that command and paste it. So I should get the curve. So this is the curve of ID by W with respect to GM over ID. So now we got all the curves for the individual length, and we know now how to change, how to plot with respect to VOV, how to plot with respect to GM over ID. So it's a very simple expression, but it is very powerful. We can plot whatever we want. And now I want to sweep the length. So just save it. And now I want to sweep the length of the MOSFET. So the parametric analysis. We have a saved state earlier. Load the saved state. Now with this, if I want to plot, if I want to simulate, I can simulate this, and it will give the value of all the parameters with respect to VGS. But I want all the parameters with respect to GM over ID or VOV. So let us wait for the simulation to complete, and after that we can export the ocean script for the parameter sweep also, and let's wait. So it will not plot anything because we didn't enable any of the plotting. But the plotting is not important because we know we will get all these parameters with respect to VGS. So what we are interested is in the ocean script. So we can create the ocean script for this parameter sheet. So I am renaming it as param and mouse. Okay, close it, and we can in the simulation directory we can see that ocean script. There is a param and mouse here. So open the file. So we have all these. So these are the parametric values of the length, and everything is similar. If you just read this file, you can see it is showing the what is it similar we are using, where is the design location, the result directory, the model file, definition file, everything is here. So if you want to plot every thing what we plot earlier, just copy paste, just copy the plotting commands that we did earlier and just paste it here. Save it and let us run the ocean script. I want to load. So copy, paste. Here it is param and mouse. So I want to name as param and mouse and let us run. So by just running the simulation, it will run all the parametric values and it will do the DCC and it will store all the parameters for different length and it will plot, we will get the 4 plots. So if you want, if you are interested in any other plot, you can add more sub window. But if you add more sub window, each window will be smaller in size. So that's why I'm not adding. So you can save here any parameter that you want, CGG, CTD, or whatever the parameter you want, you can save here, and you can plot also. But I'm plotting only 4. So just enter, and you can see it will run all the simulation with the sweeping. So let's wait. So now we got all the expression, all the parameter what we got, and we got the curves for different lengths. So you can see this is for the 500 nano and this is for the 0.18 minimum. So, so you can interpret all these curves, and we will explain all these curves later. But now we our aim target is to generate all these curves. So now all these x-axis is with respect to GM over ID, and these are the curves that we target. These are the curves that we use for design when we use the GM over ID technique. So if you whatever the curves that you want, we can generate using the simple commands here. You can change the x-axis and you can change the y-axis separately. So we completed the tutorial for the NMOS. So we can simply repeat the same for PMOS also. So I will just do the simulation of PMOS without much explanation. Uh, so first open the schematic. Now I am not running the single simulation. I am just going to the parametric simulation and finish it because it's just repetition and there is nothing complicated in it. So parametric analysis and load, and I'm just generating the ocean script. Now I am writing param PMOS dot ocean save. So you can see the param PMOS dot ocean here, and it has some plotting expression. So you can make it as comment or you can simply delete those lines because I don't want the plot. All those plot will be with respect to VGS, and I'm not interested in the plotting with respect to VGS. So you can make all of them to comment, and you can run. So before running, you can simply copy this floating instruction which we did for NMOS because we did the expression, all the parameters names are same for both NMOS and PMOS. You can simply copy all this file and simply run it. So I save this, and in the command window, instead of param NMOS, I'm just giving param pmos.ocn and simply run it. So it will also take some time to sweep all the length, and it will give us the plots, GM over ID plots that we are looking for. So let's wait for the simulation to complete. These are the GM over ID graph curves or plots for the PMOS, and here this is the GM over ID with respect to VOV, and this is we can see what we plot. So second curve is GM over ID in the x-axis and GM by GDS in the y-axis. The third curve is GM over ID in the x-axis and FT in the y-axis. So if you want to plot with respect to VOV, you can simply replace this by VOV. And if you can plot with or any parameter with respect to any parameter, there is no problem in doing it. And I think we generated all the plot, not all the plot, we just showed four plot, but whatever the parameter that you are interested, you can simply add the parameter to the test, and you save the as a question script, and you can simply copy and paste here whatever the parameter you want to plot with respect to what parameter, and you can plot almost anything versus anything here. And I think now you are confident to generate the GM over ID curves for using the Cadence. But in the next tutorial, we will explain how can we save all this data into a file and read that file in MATLAB and plot the GM over ID curves in MATLAB. So let us go to the next session and see how this plot look in MATLAB.